Yeah, so first of all, thank you very much, everyone, for this opportunity. And here I wanted to show something that we have been building on top of 10Edge. In summary, what we are trying to solve is that, teams usually train their machine learning models in the cloud, but getting these models to actually run on edge device is usually messy. So, every use case, it ends up with its own custom code, different models, its own way of deploying, and so on. What we were trying is we wanted one clean way to do this. And this is something I want to walk you through today and also get your feedback whether this approach will be useful or if it makes sense or if there's any improvement required. At the end, I would also like to show you a demo. So this demo is basically a thermal analytics use case that we are building together with SAP. And in the end, what it does, it performs inference on some thermal IR cameras, infrared cameras, and then integrates the results directly with the SAP APM Visual Inspection Manager. So, first of all, let me just walk you through this architecture from left to right. So on the left, you see that you have this edge device. So in the end, it could be a Raspberry Pi, industrial gateway. It is connected to some kind of equipment. So for example, it can be a camera, it can be a sensor like for vibration and so on. And ThinEdge is basically running on this device. So that means it handles the device management and sends the telemetry data to Cumulocity like it normally does. And now look at the right-hand side. This is where the AI and machine learning training happens. So this part is usually outside Cumulocity. So that means data scientists, they can use their own preferred tools like PyTorch, TensorFlow, scikit-learn, and so on. So we do not own this part. We do not touch that part because they can simply use or train their models, and then in the end they can export it. And here is an important part that they can export the model in a format called ONNX. So in case you don't know, ONNX is an open standard for machine learning models. And one very interesting thing about ONNX is that you can train your model in any framework you like, and then you can simply convert it into the ONNX format. So it is interoperable in nature. And after that, once you export the model to ONNX, you need only one runtime or one machine learning engine to execute it. So that's why it's quite effective because it does not matter which framework you used originally. You can actually execute them in simple, common, and interoperable ways. So here, the train model basically comes out as an ONNX file. And now the next question is, how do we get this model onto the device? And this is where the new piece basically comes in. So this is the ONNX Pipeline Runner. So ONNX Pipeline Runner is a new open source component that we have recently built. And what it does, it is basically packaged as a normal Debian package. So you can upload it on Cumulocity and you install it on the device through Cumulocity's software repository. So that means this uses the same software management flow that ThinEdge already has. So nothing new to learn here. And once it is installed, the runner basically sits on the device. So it is quite generic in a way. So it does not know anything about the model. It can be a thermal camera, it can be a vibration or anomaly detection model, and so on. So it doesn't know anything about the models. It's simply an engine that runs pipelines. So what makes it actually do something? So here is the pipeline that comes into the picture. So a pipeline, when we work with machine learning models, the standard practice is that there is a pipeline, and this pipeline basically consists of three files. So the first file is basically a preprocessor. So preprocessor, what it does, it takes the raw input from the device and it prepares it for the model, for the machine learning model. And it can be different from the different type of models. So the pre-processing for an computer vision model is different from anomaly detection model and so on. So that's why this preprocessor is quite important. And the second file is the model file, which is the model.onx. And this is the actual trained model that basically was created using these kind of AI/ML training environment. And the third part of the pipeline is the post-processor. So what it does, it takes the output of the model and decides what to do next. So for example, based on some results, raise an event, or send an alert, or maybe trigger an action on the device. So that's why these three files are quite important whenever we work with any kind of machine learning model. And these three files, they actually together form a pipeline bundle. And all these pipeline, they are stored or managed in Cumulocity's configuration repository. So here, they are versioned, they are managed centrally. So for example, in this case, you can see that I have two bundles available in this figure. So here there's a thermal analytics, there's an anomaly detection, and each one is just a bundle of those three files. So using Cumulocity's configuration repository, you can actually push these bundles or these files directly to the device. So if you push a thermal bundle, then the new device does the normal thermal analytics. If you push the anomaly bundle, then the same device now does anomaly detection. So in that way, it is same runner, no code change on the device, no redeployment, and so on. And this is actually the key idea that we were working on, that we can have this one runner on the device, and then based on that, we can actually work on many different use cases which are managed in similar ways centrally from Cumulocity. Uh, Maybe one point I want to mention is that this basically here the runner, the ONNX Pipeline Runner, as I mentioned, is an open source, and it is currently available on our GitHub repository. So anyone in the community, they can have a look at it, use it, or contribute to it. So I will share the GitHub link very soon with all of you. And maybe the last part of this architecture is when the pipeline runs on the device, the results, they are sent back to Cumulocity, maybe as normal measurement, events, or alerts. And similarly, you can also have some kind of microservices or streaming analytics that can forward these results to other systems as well. So in our demo, basically, I will show that we send the results directly to an SAP APM Visual Inspection Manager using some kind of microservice, but it can also be any downstream system you like. So in a nutshell, this is how the overall high-level architecture that we were considering for ONNX Pipeline Runner. So let me quickly show you one concrete example that we are working or building together with SAP. So here, as I mentioned, it is a thermal analytics use case. And the setup actually looks like this. So we will have a thermal infrared camera connected to a device that runs thin edge. And thermal cameras, if you don't know, they produce something called radiometric images. So that means every pixel in the image, it carries an actual temperature value, not just an image. So for this demo, what we did, we actually used some synthetic thermal frames from a simulator. And what we did, we sent these 8 frames into a pipeline. So you can see here that most of these frames are normal, but the last 2 frames have some kind of hotspots. So where temperature is much higher than expected. So here I defined a threshold of 75 degrees Celsius. So that means in this area, so in this region, the temperature exceeded that 75 degrees Celsius threshold. And then when a hotspot is detected, 3 things happen. So first of all, the ONNX model, it draws a bounding box or a heat grid around the hotspot. Then an event raised in Cumulocity with this annotated image. And then the same image is converted into a JSON payload, which is then sent to an SAP APM Visual Inspection Manager. So, the effectiveness of this workflow is that inspection engineer, they do not have to log into, separate AI systems to check the results. So these AI insights basically coming directly from the device, and they can be directly sent to the tools that inspection engineers, use every day. So here they can actually review the finding, validate it, act it as part of their normal maintenance processes. And that way, this AI becomes part of their workflow. So let me quickly show you how does it look like. So here you can see that this is my Cumulocity tenant. And as I mentioned, in the management, we have this software repository, configuration repository, which can be used to manage these files. So here in this part, I actually uploaded the ONNX Pipeline Runner, which is available as part of our GitHub repository. And similarly, in configuration repository, I manage all these bundles, these pipelines. So here you can see I have 2 different pipeline bundles, one for thermal analytics and one for anomaly detection. And each bundle has these relevant ONNX file, pre-processor, post-processor, and so on. And here in this part, I have this device, which is connected to Cumulocity using thin edge. So in this device, using the software tab, first of all, I can push the relevant ONNX Pipeline Runner. or I can install that software directly to the device. And then maybe if I move a little bit further, yeah, then using, once you push that software artifact, it basically gives us three different options to upload our pipeline preprocessor, post-processor, and model file. And now again, using configuration tab, I can select and pick and choose which pipeline bundle I want to use for performing inferencing directly on the device, and then simply send this configuration to the device. So in this case, I'm working on thermal anomaly or thermal detection use case. So I simply selected the relevant files, preprocessor, post-processor, and model, and pushed it directly to the device. But in the same way, you can actually manage different other types of AI model or ML model pipelines and push it. And now in this part, I am actually going to the console of this device. So maybe if I simply forward a little bit. So here you can see that in this part, I'm now started the TH Pipeline Runner directly on the device. So what it does, it basically starts the relevant activities. So for example, MQTT connected, the preprocessor loaded. So here I actually inserted the preprocessor, post-processor for thermal detection, and also the ONNX model loaded directly on the device. And it shows the relevant input and output structure for that ONNX model. So for example, input here is a pixel array or matrix with 120 into 160 pixel. So this is the image that will be received by this model. And the output will be a maximum temperature and also the heat grid, in which region basically the temperature is exceeding beyond the threshold. And now you see the pipeline has started running. So that means it has started sending the input frames from that simulator. And if nothing happens, then, if the temperature is below the threshold, then nothing happens. But as you see, as soon as the temperature exceeds that particular threshold, it basically raises an event. It shows the maximum temperature, which is 87.7, and also the bounding box, which is the heat grid, that in this part of the region, the temperature is exceeded beyond the threshold. So in the similar way, I can now see or go to the devices events tab, and I can actually see all these details directly on the Cumulocity devices event tabs. So here in this part, you can see that the event is generated. The temperature is 87, and this is the annotated image generated by the ONNX model. And these are the relevant JSON structure which was recorded by the ONNX model. And then, as I mentioned, there is an additional step, which there is a microservice which basically converts this JSON output from the ONNX model and converts them into a JSON payload, which is understood by the SAP APM Visual Inspection service. So here it basically converts them and also sends that result with the annotated image directly to SAP APM. So here in this part, I can actually go to the SAP APM and I can see the same annotated image on their service or on their portal, where the visual inspection engineer can actually validate these results directly from the AI model. So, very quickly, this is something I wanted to share with you very quickly, that we have created this demo together with SAP. In the next week, we will be deploying this demo in their SAP Waldorf facility. And the infrared camera is already being ordered and is currently being shipped. And then we will replicate the same demo as part of their factory. Maybe this last slide from my side, that as I mentioned, this ONNX Pipeline Runner is currently available as part of our Cumulocity GitHub repository. So please feel free to have a look. I've also provided many options, many demos here. So it's also this simulator thermal analytics. So it can very easily be replicated on any device, or maybe even on the TH demo container. So yeah, I'll be happy to have a feedback and review from you if it can be used for other customer projects, or if it can be improved with some additional features as well. So yeah, this is something I wanted to share with you today.
Yeah, awesome. Looks great. Maybe a question from my side out of curiosity. What kind of resources are required to kind of run the model locally to do pre-processing and then send it on? Is it something that you kind of need? It's more for a kind of like higher power gateway device, or do you have any kind of like? I assume it would be more than a single core kind of CPU. Do we have any kind of rough kind of? It needs so much memory or recommended CPU?
So, I mean, I tested it with 2 or 3 different examples. So, I mean, it really depends on how big the model, machine learning model you are using. But in this case, as I mentioned, I'm working with this ONNX standard. I mean, the advantage with ONNX is, so as I mentioned, it is first of all interoperable. So you can convert any model into the ONNX format. But on the right-hand side, it can also be deployed on different targets. So that means the model that you are creating for cloud, which is usually bigger in size, you can also optimize it or quantize it in order to run it on some resource constrained devices on edge. So in this case, I used some ONNX model, which were approximately 3 megabytes or maximum 4 megabytes.
Okay.
And that really worked very well on Raspberry Pi, also on our TH demo container. But if the model is quite complex, then of course we need to see how can we make it more efficient.
Yeah. Okay, cool. I was expecting kind of gigabytes, if you talk about any kind of like larger LLM models.
No, yeah. For language models, usually they are bigger in sizes. But if you're working on anomaly detection or maybe some kind of lightweight computer vision blob, then it is possible to quantize them and make it quite lightweight. Yeah.
Yeah, fantastic. Yeah, no, thanks. Looking forward to getting more outreach, and yeah, I can only encourage look into the projects, spin it up, and that's what the demo container is really there for, to have this kind of lightweight throwaway image that you can quickly spawn things and then try these great community projects out and give feedback to them. Fantastic.
Yeah, thank you.
Cool.